Show me if you want. Wait. You did sign the consent, by the way. You signed the dual canvas. One of the form they asked you.
You left so many dots about. Yeah, it's like pissing me off.
Bottom right.
It's kind of hard.
Leave him alone.
Bottom
That's
right.
not gonna do it.
Yeah, no, I
Bottom
honestly.
everywhere. Top,
Spray the whole
middle,
board.
down, up.
Spray the whole board.
We'll just have Emilio clean up
Yeah, maybe it was part of the
Yeah,
profession.
okay.
Look at his handwriting, we know he's a professional.
Emilio's skills are better.
Walks on and walks off, come on guys. You guys on
Get all the spots that you have.
That's that green dot on the side over here on the right.
the. Stop being picky. Leave him alone, Jesus.
You wanna help out too?
Yeah.
Our friends is moving.
If it bothers you that much, you can come home. You do lacrosse, I'm pretty sure you know how to do a lot of it. Look, I'm gonna leave that
Been a while?
just to annoy you. I'm gonna leave that spot right there.
my glory days.
I'm gonna leave that spot.
Okay, so, some of the limit question that, we're doing, so we talk about all kind of math. We talked about what, we'll start with limits. This is a bad mark here. Oh, no, that's good, so I know that. We say, first thing, we always just plug in the value, right? And if we're done, then we're done here, but normally it's not like that. You plug in a value. You're gonna get three different situations. So the first situation is you get 0 over 0, and we say let's do math. And we say what kind of math? 1. We can do I don't know. Factoring cancel. Thank you. My brain, my mind is factoring and cancel. Okay. And the 2, we got radicals, which is a conjugate. And 3 is combined fractions. And sometimes even I add trig limits. For example, trig limits is a limit. So for limit x approaches 0 as sine of x over x, which is today's homework, you're gonna have that, is equal to 1. Right? And limit x approach to 0 of 1 minus cosine of x over x is equal to 0. So those are the 2 things. Combine, sorry. And then sometimes in your homework, nobody did ask those questions, unfortunately, but sometimes you do get second options, which is a number over 0. And you will get number over 0 at times. Number over 0 is going to get 3 different results, but in terms of graphing wise, when's the situation that you get number over 0? On internal graph, what do you expect? What?
Asymptote.
There was an asymptote, right? So asymptote can occur in several ways. Asymptote can occur in this way, right? So say if I have asymptote, it can occur in this way, or this way. So layer 1, 2, 3, 3 thing can happen on asymptote, especially vertical. Vertical can either go up or down, whatever. So pretty much at here, you're gonna have, when you have number over 0, that means you have to do something called one-side limits. One-side limits. So what's the result of this? Well, Result list can be varies. One is can be does not exist. When you have going up and going down, that does not exist. So this one does not exist, right? It can go with positive infinity. It can go with negative infinity. This part is going to positive infinity. This part is going to go to negative infinity. So in terms of graphing, that's what they present. But in terms algebraically, that you're going to have does not exist and positive infinity and negative infinity. Okay, so how do we determine that? You're going to do something called one-side limits. What is one-side limits? You're going to say, well, we're going to give you an example. You're going to plug in the value from left and right of the left. And it's going to be really, really close. So at least like 0.1 away from the limits, okay? 0.1, okay? 0.01, 0.02, doesn't matter, something you plug in. And then you're gonna check the sign of the result. You not necessarily check the value, you check the result, whether they are positive or negative. So they are positive or negative, they're gonna get you an answer. So that's a think about, okay, so there are a few situations. Just say, what if I wanna find limit as x approach to 2 at 1 over x plus 2, negative 2, sorry. So this one's negative 2. What will happen if I plug in the value?
1 over 0.
1 over 0. So would that be this qualification? But again, you can visualize the graph of 1 over x plus 2. So that you can work on the complication problems. So 1 over 0. So then you say, well, 1 over 0 can go to positive 3 ways, right? So positive, negative, does not exist. So you should do one-side limit on both. So reiterate, one-side limit is going to determine which one the case is going to be. So we're going to plug in limit as x approach to negative 2 from the left side of f x plus 2. So if we say 0.1 is the difference, which number I would plug in? From the left side though. What is it? No. Negative 2.1. So what you're going to do is you're going to plug in negative 2.1 in there. And you're going to actually plug in a value, right? That's equal to negative 1 over what? Negative 2.1. So we know it's negative. But imagine that number is getting closer. If I say negative 2.01, right? So right now it's negative 10, right? If I plug in a closer value, what am I going to get? If I plug in negative 2.01, what is this value is going to be?
Negative 100.
Negative 100. So if I can plug in a closer and closer and closer value, eventually it's going to go to negative infinity. So if this sign's negative, that means I'm going to get you negative infinity. And we're going to do the same thing. Negative 2 to the positive 1 over x plus 2. So now which number I will plug in? Negative 1.9, right? That's equal to, well, in this case, it's going to equal to 1 over 0.1, which is positive value, which is we know is going to positive infinity. So you see the graph, that's how I ask my student to graph in my pre-calc class. I ask a student to graph the asymptotes by testing how do they behave. Are they going to positive infinity or negative infinity in terms of graphing like a big, huge rational expressions? I'll ask you that. So that case is gonna be, in this case, it's gonna be negative infinity, positive infinity. What is the result is going to be here? Does not exist. Because due to those two, right? Can I ask you individual one? Yes. On the test, I can ask you individual one. I can also ask you this one. Am I confusing anybody? So can you do this one? Limit as x approach to, I don't know, -4, 1 over x plus 4 to the square. What do you think the answer is going to be? Remember, you had to check from both sides. So, plug in the value from left and right, and then see what happens. But most of you guys can think a little bit, you guys know what it's going to be. But you still have to show me the work on the test though. If you just say, oh yeah, the answer is does not exist, I don't know what does not exist, how do you justify that? Can you justify that? Can you justify anything that is what you said? You cannot say, oh, limit does not exist because Mingo told me, right? You had to be able to justify how you're going to come in does not exist. I'm going to ask you guys in a bit. I'll give you a couple of minutes to work it out. So do you understand what's off-axis rotation now?
We just like shift it, kind of like shift it, like use those values.
But how do you assign the variables?
Just like, it's like determine the distance basically.
Right. To the axis rotation, from the axis rotation to the curve, and from the axis rotation to the curve.
Yeah.
So how do you design that internal variables?
Basically find the area of the washer and then integrating that.
Did they go through shell method over there?
I haven't gotten there, if they have.
No.
Like only on like page 6 or, yeah.
But there's a restriction on washers. Not all questions could be done with a washer. So some question has to be shell only. That's why you need to learn both internal calculus. So Natasha, what do you think the answer is?
Positive infinity.
Positive infinity, why?
Well, if you just look at it too, like you're squaring it, so you're getting rid of the negative.
So if in terms of graph, which one will belong? This one or this one or this one?
The second one.
This one,
That
yeah, you're right. And I call it a volcano graph because it looks like kind of like volcano on top. So it kind of like, but that's the idea if you have this. But you shouldn't approach from both ways though. You had to prove it. Okay, so -4 to the left side, right, of x plus 4. So you're gonna plug in what? Which number are you gonna plug in? 4.01. So there will be positive infinity and limit x approach to -4 from the positive side of 1 over x plus 4. That's equal to positive infinity. Therefore, it's positive infinity. And that's going to help you do some questions over there. Okay. So you get number over 0. You have to do one-side limits. And you have to think about what is one-side limits going to be. How do you establish those one-side limits? Alden, if you don't move your seat up here, you can. Questions about this part? Now, on homework question, there was one question I really like. It says, limit x approach to 1 of x squared minus 1 over absolute value x minus 1. Do you guys remember that question? Did you guys do that one?
Yeah.
Okay, so we're gonna go over that one. So that one's kind of in between those two places. You had to do one-side limit, so you had to do absolute value, you had to do one-side limit. But that part of the graph is actually very interesting. So I'll go over that one particular one because it is one of the things that a lot of people have wrong. Now, whatever I'm going over is beyond what AP is asking you. I'm not gonna just do what APs ask you to do, which is, that won't be sufficient when you go to UCF or even other college classes, MIT, whatever. So I'm gonna ask you a little bit more. In MIT, actually, they want you to understand more limit than this. They actually want you to understand the delta epsilon. And they had to understand all the details of it. In UCF, I think they do too. I don't remember. But I didn't see their first test. Let's see their final exam. So I think the question says limit like this. Do you guys see this question? Yes or somewhere? Yeah. And you're like, how do I even approach this question, right? Well, we know that downstate here is x minus 1 is absolute value. So those are actually piecewise functions. Does that make sense? So if I just look at the bottom, that you should get x minus 1 when x is greater than 1, and you should have this when x is less than 1. So we're gonna assume that this one is just the bottom part. Now, we're gonna say this one's f of x, so if it's an f of x, it's gonna be limit x approach to 1. On the left side, we're gonna say x squared minus 1. On the left side, which equation I will use? Second one, right? It's less than 1, right? This one, x equals to 1 positive side, be x squared minus 1 over x minus 1. Does that make sense? Let me know if you have any question, because I don't want to move on until you got all the question answered. I still had to do 2 separate sides here, because if I plug in 1, I get 0 over 0. But since this is a square root, since this is absolute value function, there's no way for me to do factor, cancel. There's no way for me to do what? Radical. There's no way for me to do conjugate. But there's a way is to break down in terms of functions. Which function from the left and which function from the right. If I remember, this function is going to be, if I just graph x minus 1, that means shift right 1. This side is going to be x minus 1. This side is going to be negative x minus 1. Then what happened? If I have this x squared minus 1, so we limit as x approach to 1 from a minus sign, that's going to be x plus 1 and x minus 1, right? And that's going to be limit x approach to 1 from the left side of x plus 1 negative. Still one side limits. So it kind of was hybrid between the first case and second case. Then that's going to give you negative 2. In this case, it's going to give you 2. It turns out the graph going like this, positive 2. And this one is going to go like this. It's actually very much like the graph, like going like this, but except now it's sideways. So it's a little bit more intensive for us thinking about it, because you suppose graph this function on the left side and graph this function on the right side, x plus 1 on the right side. So x plus 1 is like here, but you start at 1. Move up. Here it's going to be the other way. You should intersect at negative 1 here. So it's kind of hybrid between 2 situation, because you really cannot do any of those math thing. we really had to do it, break down the absolute value into piecewise. And we're gonna keep on covering this because this is gonna be something that's very easy somewhere down the road. Questions? How much time I have?
I'm checking that right now.
12 minutes? Okay, we're gonna talk about continuous. Is this function continuous? No, there's a gap, right? Okay. So we're gonna start by talking about this. Now we're gonna talk about definition continuous. What is definition continuous? Well, for me, continuous is this. It's like you want a roller coaster to be that way, right? You don't want to have roller coaster going like this, right? Hopefully. I always tell people, unless you're in a first and verb, then you can have roller coaster like this. Because somehow you're gonna have like something like a rocket going like here and going back down, and like maybe a spring down here. You can go in here and bounce it off and go to the next stage, that's the idea of, I mean, I love the cartoon is awesome, it's probably the most innovative cartoon there is. It's Fearless and Verb. My favorite part is they fall in a hole, and it's an infinite hole, and they just keep on falling. You know what I'm talking about?
You seem happy.
And they scream the first 10 minutes, right? And they're like, wait, why am I screaming? I'm not landing. So he just like, they start talking to each other. And that's my favorite part of the cartoon, is that infinite hole that they fall into. So it was really interesting. So for me, in order to, the function is continuous, really, you want it to be, those two things are connected, okay? So they're not only connected, they cannot have a hole in between them, okay? So the idea is,
Whoa. You
Sorry.
get it?
No, I didn't get it, I don't think he died. Okay, so, how does a function to be continuous? Okay, so, continuity. So we're gonna talk about continuous. So what's a requirement for function to be continuous? To be continuous. I have no idea how to spell continuous, so you guys gonna help me out. CONTINUOUS.
I don't know.
Okay, continuous, that looks good. So first thing, the requirement is this. It sounds like a very simple requirement, but it's always tested. It's so often tested that people, every time you see this, people just avoid it. They jump over, they say, I'm not doing this. But the problem is, they're not hard. A lot of people just prefer to be that hard. So it has to be in sequence, okay? First requirement says f of a has to be defined. What does define mean? It has to be a closed circle. It has to be defined. It has to have a value. If x equal to a is, for example, f of 2, the f of 2 actually have to offer you a value. Cannot be says does not exist, or f of a must be defined. So that's the first conditions. Okay? And you say, okay, if f of a is defined, what are the requirements needed in order for the function to be continuous? Can you name one? Are we trying to do a staring contest? Because I can win for sure. What's the condition that you think it has to be there. A function to be continuous.
No gaps.
No gaps.
Like
How do
that
I
one.
create no gaps? That's a good idea, no gaps. But how do I create no gap? Oh no asymptote, right? How do I create a thing? What do we talk about? Limit has to exist. Right? Limit has to be exist. So what does that mean? That means limit as x approach to a of f of x has to exist. Right? So what does that mean? If limit exists, that means limit x approach from a from the left side of f of x must equal to limit x approach to a from the right side of f of x. Now, do you think that's enough for a function to be continuous?
No.
Why? You're right. Do you know why that part has to be continuous? What else is needed to be continuous? You said no. You must have a reason why you say no.
Sounded like you wanted us to say no.
No, but you gotta start thinking. Can I create a graph that limit exists and the f of a is defined, but still not continuous? How do I do that?
Like that, absolute value graph.
Well, that exists. Well, that
But it's-
is continuous.
Is it?
Yeah, its absolute value is continuous. It's not differentiable, but it's continuous.
Doesn't have
You're
to be
talking
diff-
about differentiable.
Oh, doesn't have to be differentiable to be continuous or no?
No.
Oh, never mind.
So that's good idea. See, now you find out something you don't know. It has to be continuous in order to differentiate.
Oh, so it's the other way around.
But if it's differentiable, it's automatically continuous. So we can talk about a pyramid. Actually, we did talk about a pyramid.
Yeah, I thought it was the other way around.
No. Okay, so somebody raise a hand. Do you know what is the third condition must be needed? Or can you give me a scenario that's not continuous, even if it through the first two requirements? I'm using my real eye. I still can give you. Come on. Can I have this situation like this? Does limit exist here? And I want to create fa is defined. Then I say, hey, fa is defined. Is this function continuous? No, it's still a hole. You don't want to have a roller coaster going like this. It's still going to be like, right? So you don't want it to happen. So you want to be, pretty much. So then what do I have to do? We have to say limit x approach to a from the, both sides. We can assume that's going to be both sides already. It's equal to what?
F of A.
F of a. So I have to say this solid dot, it has to be here. And that's why I say kind of like a roller coaster that might work. Of course, you don't want a roller coaster going this way, but ideally it's semi-functional, right? So that's to be continuous. So those are three requirements for you to be continuous. It has to be in this order. F of A has to be defined. If it's not defined, don't even talk about it. Because that means I don't even have a solid dot there. A solid dot could be a line, could be like this. That's still, I don't have that doesn't exist. Limit left to right does not equal to each other, it's gonna create a gap. And here is what does not create a gap. So those are three conditions. Okay. What is those three conditions is always tested. On every single test, at least 2 questions to 3 questions, that is tested on every exam. But it does not mean that people get it. People don't get it actually. People avoid them when they talk about definitions. People just say, I'm gonna pick A, B, C. C sounds good, pick, done. And see, always never the answer. Okay? But later we're gonna talk about what is the requirement for function to be differentiable. They are a little bit different. So we're gonna go back to talk about this in the pyramid scheme. And in terms of pyramid, I kind of invented throughout the year. Okay? So any questions so far? Today you're gonna have trig limit worksheet. There's an answer there. You just have to find a way how to math get there to make it work. Second, you're gonna have some absolute value to deal with. Okay. You gotta know how to deal with absolute value. Absolute value is not difficult, but later on we're gonna have to deal with more because we can talk about differentiable and integrations, which is area under curve. Which is you don't even have to do integrations. Just count out how many triangle it is and define how many triangle it is. You should expect a test next week. Probably not Monday, probably Tuesday. Okay, I don't try to test on Monday. Monday is a bad test day, right? That'll be out. Make sure you do your homework. Otherwise, I have to kick you out of the classroom. So I don't want to do that. I'd rather you be here and enjoy with us.